Welcome. In this video, I'm going to show you how to determine whether three vectors are coplanar. In order to do this, we just need to verify that the volume of the resulting solid that would come out with these three vectors here. So these are clearly not coplanar vectors. As you can see, they're not in the same plane. But if they were coplanar, if you notice, the solid form, well, wouldn't actually be a full solid. It would just be this flat shape with a volume of 0. So we just need to determine that the volume is 0. In order to do so, we want to take the dot product of U with the cross product of V cross W. So let's start by finding V cross W. So this is I, J, K. I'm just setting up the matrix. All right, and we have I, and then the matrix is -1, -9, 4, 18, minus J, 2, 0, 4, 18, plus K, 2, 0, -1, -9. So I end up with I times -18 plus 36 minus J times 36 minus 0, so I'll just write that as 36, and then plus K, and this will give me -18 plus 0, so I'll just leave that as -18. So this is 18I minus 36J, not plus, excuse me, minus 18K, or we can write this as 18, -36, -18. All right, so now that we have that, we can work out what U dotted with this cross product is. So U is equal to 1, 4, -7. And we're going to dot that with 18, -36, -18. So this is 18 plus 4 times -36 plus 7 times 18. And what does this work out to be? 18 plus, oh, excuse me. I'm going to write this as -8 times 18. You notice I just factored this into 2 times 18 plus 7 times 18. So what this shows me is that I have positive 18s added 7 times and then subtracted 8 times. That in D is 0. So these vectors U, V, and W are coplanar. Now, as a quick aside, I'll go ahead and open up GeoGebra just to make sure you understand what is happening visually. Okay, so once you visited geogebra.org, click on this little 3x3 grid here, go to Classic, and then 3D Graphics. And let's go ahead and type in vector, and if you haven't done this before, you can always scroll down and see what you can select for your vector. You can put in 2 points or 1 point. I just need 1 point. And my point for V is 1, 4, -7. There's V. Let's do this again. My vector for U is 2, -1, 4. And then one more time, vector. And make sure you put a double parentheses there. This inner parentheses closes the point. The outer parentheses closes the vector command. You wanted to put in 0, -9, 18. And I want to verify that these are on the same plane. Right now, this is kind of far out there. So I'm going to click on this icon here, go to Move Graphics View, place this right on the Z-axis, and drag this down. And really quickly, if you're struggling to remember which is X, which is Y, which is Z, you can always put in a point, say 3, 0, 0. There's your X-axis. For Y-axis, you can do the same thing, 0, 3, 0. There's your Y-axis. And then, of course, you can label these as, excuse me. And, of course, you can label these as X-axis, Y-axis, like I do on my demos. But for now, I'm going to leave those off. And, oh, it undid the zoom I did. That's too bad. So let's go ahead and zoom these out. I just want to see the tips and tails of all of these. And this one dotted is below the XY plane, but I don't really care about that. So I just want to see the grid. And let's go back to rotate graphics view and let's take a look. These should all be on the same plane, and indeed it does look like they're on the same plane. Now, as you can see, I've selected this tool here, and I selected plane through 3 points, and so I'm going to use these 3 endpoints as the 3 points for my plane. Let me just type in the command plane. And I want this one, point, point, point. So for my first point, 1, 4, -7. For my second point, I want 2, -1, 4. And for my third point, I want 0, -9, 18. And as you can see, now let's go back to rotate 3D graphics view. All our vectors are on this plane. Isn't that cool? You have just demonstrated using both calculus and technology that these 3 vectors are coplanar. I hope you found this video helpful.